Pre-calculus. We are going to talk about the law of sines. It is a very interesting formula which allows you to solve a triangle. And in this case, you actually don't need to have the right triangle. So this lecture and the next lecture on law of cosines, you do not have to have a right triangle like you always had to have them in chapters 4 and 5. So now, for any triangle, doesn't matter what that triangle looks like, and here is the obtuse. So whatever the triangle looks like, we are going to have these A, B, C angles, and then sides are always what I say across the street, right, from where the angle is on the opposite side. And the law of sines says that A divided by sine of A is equal to B over sine of B is equal to C over sine of angle C. That's law of sines. But it's very important to make sure that you are always using capital A and lowercase a across from each other. As you can see, C and C, and B as well, right? It doesn't matter where you put A. If I am to change this to A, then I have to change this side into A. They have to be across from each other in order for this to work. So, if A, B, and C are the measures of the angles of a triangle, which does not have to be a right triangle, so any triangle, and lowercase a, b, and c are the sides on the opposite sides, then the ratio of lengths, right, to any of the angle is the same. So now, how does that help us with our solutions? Well, we just need one more formula here, which is the one you know. On flat surface, a plus b plus c equals to 180 degrees. That's another formula that will help us go through this. So now, if you are given some angles and lengths, you can figure out the rest of the information. So solve the triangle given that, and I'll just make up some stuff. Let's say A is equal to 43 degrees. Angle B, let's say, is given as, I don't know, 60 degrees. And side B is, let's say, 50 centimeters, let's say. So we can draw this. Now we see that these two angles are less than, they add to 103, right? So it's going to be one of these triangles without obtuse angles. And you can put your ABC anywhere you want, but then the sides have to be carefully placed so they're opposite of the angle. The A is 43 degrees, nice. B is 60 degrees, okay. And the length of side B is 50. So B is 50. We can immediately calculate C because it has to be 180 minus the sum of the other two angles, right? Because together they all have to give 180. So if these two are 103, then this must be 77 degrees. 77 plus 103 is 180. So we found already that angle at C is 77 degrees. When it says solve the triangle, you are looking for the measures of all three sides and all three angles. So you have to have all of those. So we have all three angles. Now we just want to find the sides, and that is where your law of sines kicks in. So A over sine of A is equal to B over sine of B. And you can calculate side A using this part of the formula. Formula is a triplet, right? So you can pick any combination. So we don't know A, but we know it's going to be over sine of 43 degrees. And then we know that B is 50 and sine of B, which is sine of 60 degrees. So all you need to do is to multiply sine 43 into the right side. So A equals 50 over sine 60 degrees times sine of 43 degrees. And once we use this, right, we use the calculator to compute this, we will have the value for. Now, sine of 60, we don't need the calculator for that. That's root 3 over 2. But then 43 will give us decimals. So now we're just going to get everything as decimals. So I'm going to use my calculator first mode, and I'm changing into degrees. That's important. Always check your mode first if you're going to use calculator. 50 times sine of 43, closed parenthesis, divided by sine of 60, and the decimals are 39.4. I'm using one decimal because the original number given to me, 50, had no decimals, so you are allowed to just go one extra decimal. Now, can I use Pythagorean theorem to figure out the third side, now that I have that A is equal to 39.4? Can I? Can I? Can I? I guess you guys fell asleep, huh? The answer is hell no, because it is not a right triangle. So we have to use law of sines again to solve for the length of C. And now you can use either A or B. It doesn't matter because you now know A side as well. Well, let's use B over sine of B is equal to C over sine of C. You can use any combination. Why did I pick B? Because it's already set up over there. And then we have now C over sine of 77 degrees, right? So C is equal to 50 over sine of 60 degrees times sine of 77 degrees. And we plug this into the calculator again. So sine of 60 divided by sine of 77. 77. 44.4. And the triangle is solved when you can list all three angles and lengths of all three sides. So angle A, 43. Angle B, 60. Those are degrees. And angle C, 77. Side A, 39.4 centimeters. Side B was the one that was given to us, which is 50 centimeters. And side C, 44.4 centimeters. this is what your answer should look like, because this answer clearly lists all three sides and all three angles. So, believe it or not, that's it. There is a special tricky case that we have to talk about, but that's it. That's the law of sines. You have this formula, which is like a three different fractions, right? And you can combine either one of them with whatever other part you want. So A can go with C, or A can go with B, or B can go with C. Depending on what you guys have, you always need to have three pieces so that you can calculate the fourth one. Now, clearly, if someone gives you three angles, you can't compute anything, right? Because you don't have a reference to where to start with sides. But then you get into something that's called similar triangles, because all of the angles are the same, and then scaling up and down, right? Now, if you get three sides, we will see a method with law of cosines that will help you in that case. But now, if you're given two sides and an angle, or two angles and one side, law of sines can quickly find the missing values. Now, we have to be careful, because in certain cases there are two solutions. So you should always check if your problem has another solution. So now, what is that case? See, if I draw the triangle like this, and I'll put this height in here, and let's call this angle A, and that would make this side to be A. I don't care about the rest at the moment. I hope you see that you can also draw A here with this same distance x from H. So that is a little bit of a scary case, because if you are given angle A, which never changes, and you are given the length B, which never changes, and you are given the length A, which never changes, but it can change the location, but that actually changes, as you can see, location for B. So it doesn't change length of A, it just changes the size of the angle B. You can have two different cases if the problem that it's given to you is side angle, right? Side angle, because this was A was given, B was given, and capital A was given, right? Capital A is the angle. So this one, side and A. So let's take a look at the problem that would have something like this. Now, these are carefully crafted examples, obviously. I mean, you can by accident run into one if you're lucky, but here. So let's say that A is given as 40 degrees, lowercase a is given as 54, and lowercase b, right, the other side is 62. So how do I know that this is one of those cases that has two solutions? I don't. I just know that it's possibility, because I have two sides given and then an angle, right? Now, granted that, right, you have to have this angle be the one that moves, right, on the side. So in this case, the way I drew the picture, it's A and A. Now, you will solve your problem exactly the same way as the previous one. And then you're going to do something interesting with the angle. So let's go solve the problem in the regular fashion. What are we looking for? We are looking for the angle at B. That's what we're looking for, because that's the only thing we can compute. We can't compute anything for C because we don't have anything for C. So the only thing that we can do is A over sine A equals B over sine B. And when you solve for sine B, you can use later, well, as we'll see, inverse sine to come up with a number. So cross multiply over here. Actually, let me plug in the numbers. A is 54 over sine of 40 degrees is equal to 62 over sine B. Cross multiply, which is 54 sine B, is equal to 62 sine of 40 degrees. And finally, sine B is equal to 62 sine 40 degrees divided by 54. Now, this is something that you punch in your calculator to get the decimal, right? 62 times sine of 40, close the parenthesis, divided by 54. And this number better be between -1 and 1. Or in this case, 0 and 1 because it's positive. But it can't be more than 1. If you get more than 1 here, you're doing something wrong. Sine function cannot have the range bigger than 1, right? The range for sine function is -1 to 1. Now, luckily, we have that exactly, which is 0.738. And now, to get B, use inverse sine on both sides. So on the left, it would cancel, and on the right, it would stay. So we have inverse sine of point, well, I can just say of answer because it's on the stack. And B works out to be 47.6 degrees. 47.6 degrees. All right. Now I have A plus B plus C is 180 degrees. I know that A is 40. I know that B is 47.6. So I can calculate C, as you can see. I can calculate C, as you can see. So 180 minus 87.6 is 92.4, right? Hopefully. So angle C is 92.4. And you can go and figure out the length for side C using, again, law of sines. So you can go A over sine A is equal to C over sine capital C for the angle. A is something, 54 over sine 40 degrees is equal to C, unknown value, divided by sine of 92.4 degrees. So the C, the length side, right, the lowercase c, is 54 over sine 40 degrees times sine of 92.4 degrees. So 54 times 92.4, sine of 92.4 degrees divided by sine of 40 is 83.9. 83.9. We did not have units, so it's lame. So we solved the triangle. But now, when we solve this triangle, we have to check if there is a second solution. And the way you do that is you figure out the new value for angle C. Let's go back to our picture. B. So let's go back to our picture and realize that we figured out that the B angle is 47.6. That's this, 47.6 degrees. Okay. If that angle is 47.6 and this is the isosceles triangle, both of the sides of the triangle have the same length A, then this angle has to be also 47.6 degrees, which makes this angle the new angle. Because, guys, you have the black outline triangle, and that's the one we solved. But there is another solution inside this red triangle, the obtuse triangle, and I need to find this angle here so that I can solve the rest, because I don't have the angle on top either, right? Top is C. So luckily it's easy to find this angle because you just need to subtract from 180. So second solution has a new B. You can call it B star, B prime, B whatever, and that is going to be 180 minus 47.6 degrees for a total of 132.4 degrees. 40 minus this, yeah, that will be a 3, that will be a 2, and that will be a 4, yes. So now we have the new set, and I have to go and figure out again value for C, which is the angle, and we'll call that C prime because it's like a second set. So C star 180 minus 132.4 degrees plus, and now I need the angle that I know, which is 40. And that's going to be angle C is, as you can see, a very slim angle, but that's okay. It is 7 point, right, that's 180 degrees. 180 degrees minus 132.4 degrees. Something, and then minus, well, actually I could just add this, it's 70, there we go. So 40, 3 plus 4 is 7, everything else stays the same. All right, so now I subtract this and I come up with the C star, which is equal to 7.6 degrees. So that's the second set. Now I have to run the law of sines. C divided by sine C is equal to B over sine B. It doesn't matter which one you pick. So C is the unknown. Sine C is sine of 7.6 degrees. And B is, where is B? 62 over the sine of, so which one? Hold on. We need sine B, 132.4. It's right here, hidden in plain sight, like autobots. So C is equal to 62 sine 7.6 degrees divided by sine of 132.4. And that's going to give us the second set. So 62 sine 7.6 degrees, everything divided by sine 132.4. And I had to type it twice. 11.1. Okay. So that's the second set. Why did we get it? Because the possibility of something like this happening in the triangle. And it only happens when you have side-side angle. So now we have two solutions, and let's list them. And believe it or not, that's it. So, I mean, we can do a word problem maybe if there is something nice. Yeah, well, we can do a word problem. Ooh, leaning tower of Pisa. Well, let's do that one. So let me just put the solution sets. So set 1 is going to have lowercase a 54 and then 62. So A is 54, B is 62, C is, what was that thing? 11.1 centimeters, let's say. And angles, A, B, C. So angle A was given to us. And then we had to, so 40.
For length C, is it not 83.9?
And I typed it twice. Let me see. 62 sine 7.6 divided by sine. No, this is good. Yeah, length of C has to be a very smaller number than these. Oh, you mean the previous one?
Yeah.
Instead of 132, what did you have? No, that's the angle. You said the length of the side. I have 83.9. That's what I have.
Oh, okay.
Is that what you
I
have?
just voted wrong then. Yeah, I think I just voted wrong.
Oh, okay. Okay, so angles 40 degrees for A. Old B was 47.6 degrees. and this one has to be 72.4 degrees. Set 2, A is still 54, B is still 62, but now you have a C star, right, which is 11.1. And the capital angle A, that can't change, it's 40, but B and C both changed. So angle for B, 132.4. And what else? The C is, where is C? 7.6 degrees. So 2 sets. We have 2 sets here, and this is the case that you have to be careful. So when you see the side-side angle case, make sure you are checking and subtracting that angle to see if you do have, in fact, another set. All right, let's do a word problem, and then we'll deal with. I promised the Leaning Tower of Pisa. So let's see what they have there. So we have this tower. That's too much of a lean. That is leaning. Looks like the thing for coffee. Whatever. But it is leaning at the angle of 84.7 degrees. And now, if you take a look at the top at angle 50 degrees, this length here is 171 feet. Find the distance to the nearest tenth of a foot from the base to the top of the tower. So they're technically looking at the length of the tower. Okay. If that is unknown length, call it, I guess, C, then you already have C over sine of 50 taken care of. And now you would like to use 171 with a sine, but then you don't have that angle up there, so you have to do this calculation on a side of 180 degrees minus 84.7 degrees minus 50 degrees, which will give us the angle for the sine for B. Come on, pen, you can do it. There we go. So that's what, 45.3. One more time, 80 kills 80, then you are left with 82. No. Yeah, 130, 100, yeah. 130, yes, okay. So now we have that our angle that it's opposite of 171 is 45.3. And there you go, done. C equals 171 sine 50 divided by sine 45.3. So that is going to be the height of the tower. Let's see, 171 times sine of 50 and then divided by sine 45.3. 184 0.3. There it is. I have no clue why it is given in feet when this thing is in Italy. They use metric system there. So, but whatever. 184.3 is the measure for the height of the tower, and we used law of sines. So you need to memorize that formula, that the three-sided formula. You need to memorize that, and then you need to also do the add the angles, right? So that you can find the third angle, because 171 was across from the angle whose measure was not given to you. You had to find that measure first. Now, is this realistic for us to measure the tower this way? Absolutely, because you can see angle of 84.7. Stand sufficiently far from the tower and take the protractor, right? Just put it on at 90 degrees to the ground so that you can see the tower through it, and you can find this. You can also stretch a little string or something and measure the other angle is 50, and then to wherever your stick is, right? Where the 50 is, you can take a measuring tape and measure on the ground 171 feet. That is all very easy to actually do, to measure, and yeah, you can figure out this way. We used the trig and tangent earlier, so it was right. Law of sines is you use when you don't have the 90-degree angle. So good. Homework will give you a lot of these to practice, including the two solution ones. So be careful, right, to spot the second solution. And any last chance for questions for 6.1? Law of sines. Way too easy, I guess. Okay. Well, bye.